The 737 has three hydraulic systems. They are System A, System B, and the standby system. The hydraulic systems have reservoirs in the main wheel well. System A and System B operate independently. A hydraulic servicing line connects System B and the standby system. The bleed air system supplies air pressure to Systems A and B reservoirs to make sure there is a positive flow of fluid. System B supplies pressure for the standby system. The number 1 engine-driven hydraulic pump and an AC electric motor-driven pump supply the pressure for System A. Under normal conditions, the number 2 generator powers the electric motor-driven pump for System A. The number 2 engine-driven hydraulic pump and an AC electric motor-driven pump supply the pressure for System B. Under normal conditions, the number 1 generator powers the electric motor-driven pump for System B. One AC electric motor-driven pump supplies the pressure for the standby system. System A supplies hydraulic power to these units, and System B supplies hydraulic power to these units. If Systems A and B do not operate, the standby system is available to supply hydraulic pressure to the rudder, the leading edge devices, and the thrust reversers. The Power Transfer Unit, or PTU, supplies additional volume of hydraulic pressure to operate the auto slats and the leading edge flaps and slats at the normal rate when the pressure of the System B engine-driven pump drops below limits. The PTU control valve opens when the output pressure from the System B engine-driven pump drops below limits. The airplane is in flight, and the flaps are less than 15 but not up. When the PTU control valve opens, System A supplies hydraulic pressure to operate the PTU. The PTU uses System B fluid to supply pressure for the auto slat system and the leading edge flaps and slats. If the number 1 engine fails, the landing gear transfer unit supplies hydraulic fluid volume from System B to raise the landing gear. In System A and System B, the engine-driven pumps supply a larger volume of fluid than the electric motor-driven pumps. If the left engine fails, System A does not supply sufficient hydraulic volume to quickly retract the landing gear. The electric motor-driven pump continues to operate as usual, but the total hydraulic volume of System A is less. The landing gear transfer unit operates when the number 1 engine N2 is less than idle. The landing gear lever is in the up position, and one of the main gear is not in the fully up position. The landing gear transfer unit supplies System B hydraulic fluid volume to retract the gear. The lower display unit shows the pressure of System A and System B. There is no pressure indication for the standby system. The normal pressure for the three systems is 3,000 psi. The lower display unit also shows the quantity of System A and System B hydraulic fluid in percent of full. For example, 90 shows that the reservoir is 90% full. If the quantity is low and the airplane is on the ground, the system shows the letters RF, or refill, adjacent to the quantity indications. The hydraulic brake pressure indicator shows the hydraulic brake pressure. The normal brake pressure is 3,000 psi. The controls for the hydraulic systems are on the forward overhead panel. System A and System B controls are on the hydraulic control panel. And the standby system controls are on the flight control panel. Now let's discuss the normal operation of the hydraulic systems A and B. During the safety inspection, you make sure that the electric motor-driven pump switches are off before you turn on any electrical power to the airplane. The electric motor pump switches control the electric motor-driven pumps in Systems A and B. The engine-driven pump switches control the related engine-driven pumps. Systems A and B lower the temperature of some hydraulic fluid with heat exchangers in the main fuel tanks. Before you operate the hydraulic system on the ground, you must make sure that there is fuel in the main wing tanks. The low pressure lights show that the output pressure from the related pump is low. During the pre-flight, you make sure the engine-driven pump switches are on, and you select the electric motor-driven pumps to on. Turn on the electric motor-driven pumps. After the electric motor-driven pumps are on, make sure the electric motor-driven pump low pressure lights extinguish. The hydraulic pressure increases to normal, the brake pressure indication increases to normal, and the hydraulic quantity indications do not show RF. During pushback, if the nose gear steering lockout pin is not installed, you must turn off the System A hydraulic pumps. The engine-driven pump low pressure lights extinguish when the engines operate and the engine-driven pumps supply pressure. Now turn off the number 1 engine-driven pump. When you select off with the engine-driven pump switch, a solenoid closes and holds the blocking valve, and fluid does not go through the related pump. The engine-driven pump continues to operate but does not supply pressure. During normal operations, the engine-driven pump switches stay in the on position to increase the life of the solenoid. Move the number 1 engine-driven pump switch to on. The hydraulic system is ready for flight. To shut down the hydraulic system after taxi-in, turn off the electric hydraulic pumps. The switches for the engine-driven pumps stay in the on position. To review, touch any control or pressure light. Press the green arrow to continue. During flight, there is a failure in System A and the hydraulic fluid quantity decreases. When the quantity decreases to less than limits, the master caution lights illuminate and the flight control and hydraulic annunciator lights illuminate. On the overhead panel, the low pressure lights for the System A pumps illuminate. Turn off the System A hydraulic pumps. The System A flight control low pressure light illuminates because System A pressure to the flight controls is low. Select Standby Rudder with the System A flight controls switch to activate the standby hydraulic system. Also, the field differential pressure light illuminates. These lights are discussed in a different lesson. The System A pressure and the quantity indications are low. When System A does not operate, these components do not operate. The rudder, the ailerons, the elevator, and the elevator field continue to operate because System B supplies hydraulic pressure to these units. Half of the flight spoilers do not operate. System B supplies pressure to the remaining flight spoilers. To lower the landing gear, you must use the manual gear extension handles. To supply hydraulic pressure for nose gear steering, you must select alternate with the nose wheel steering switch. System B now supplies hydraulic pressure for nose wheel steering when the airplane is on the ground. When System A pressure is low, the hydraulic pressure from the standby system is available to operate the number 1 engine thrust reverser. The standby system is discussed in a different lesson. During flight, there is a failure in System B and the hydraulic fluid quantity decreases. When the quantity decreases below limits, the master caution lights illuminate and the flight control and hydraulic annunciator lights illuminate. Reset the master caution system. On the overhead panel, the System B flight control low pressure light illuminates. The field differential pressure light illuminates. The System B low pressure lights illuminate, and the System B pressure and quantity are low. Now, turn off the System B hydraulic pumps and select standby rudder with the System B flight controls switch. When there is a failure of System B, these systems do not operate. The rudder, ailerons, elevator, and elevator feel continue to operate because System A supplies pressure to these units. Half of the flight spoilers do not operate. System A supplies hydraulic pressure to the remaining units. The yaw damper does not operate. Although the normal brakes do not operate, System A supplies pressure for the alternate brakes. When System B pressure is low, the standby system is available to supply hydraulic pressure to the leading edge devices and the number 2 engine thrust reverser. If the temperature of the electric motor-driven pumps or the related hydraulic fluid is higher than limits, the related overheat light illuminates. Turn off the electric motor-driven hydraulic pumps. The related hydraulic system continues to operate with pressure from the related engine-driven pump. The standby system is available if there is a loss of normal hydraulic pressure. To manually turn on the standby hydraulic system, you use one of the flight control switches, or you use the alternate flaps switch. With the System A flight control switch or the System B flight control switch, you control the standby hydraulic pressure that goes to the rudder. Select standby rudder with the System A flight control switch. When you select standby rudder, the standby pump operates. To verify the pump operates, the low pressure light illuminates for approximately 1 second. Also, the standby rudder shutoff valve opens, the related flight control shutoff valve closes, and the related low pressure light extinguishes. Additionally, the standby rudder on light illuminates anytime the standby rudder hydraulic system is pressurized. Now select standby rudder with the System B flight control switch and look at the indications. Now close the guards for both flight control switches. Now select arm with the alternate flaps switch. The alternate flaps switch turns on the electric pump in the standby system. The standby hydraulic system is now available to extend the leading edge flaps and slats. Standby hydraulic pressure is also available to operate the thrust reversers. Note that in this case, the standby rudder on light does not illuminate because the standby rudder system is not pressurized. Now turn off the alternate flaps. During takeoff and landing, the standby hydraulic system can operate to supply hydraulic pressure to the rudder without flight crew action. The standby pump operates and the standby rudder shutoff valve opens when the pressure in System A or System B is low and the flaps are not up and the airplane is airborne or the wheel speed is greater than 60 knots. When these three conditions are true, the standby system supplies hydraulic pressure to the rudder. Flight crew action is not necessary. The standby system operates until the flaps are fully up. The low quantity light illuminates if the quantity and the standby system is low. The light is always armed. If System A and System B do not operate, and the standby system low quantity light illuminates, the rudder, the thrust reversers, and the leading edge devices do not operate. The low pressure light for the standby system shows the output pressure from the standby pump is low. Before engine start, pre-flight the hydraulic panel. The electric motor-driven pump for System A is already on. Try again. The electric motor-driven pump for System A is already on. Try again. The hydraulic panel is ready for flight. After you pre-flight the hydraulic panel, you see these indications. Are they correct? The quantity in System A is low. Call maintenance before you continue. After takeoff, with the flaps not up, you see these indications. Reset the master caution system. Now touch the correct answer.